Hello everyone. In last lecture we have studied rule 1 for integration under differentiation sign. So in that case what was rule 1? Rule 1 is nothing but having limits for integral as constant. So in that case when I try to differentiate this with respect to a, what it must be, I need to show that this is equal to log of b by a. So let's start with that. Again, denote this by I of a. B is also present here, but we'll always go with I of a here. Okay, so this is from 0 to infinity, e raised to minus ex minus e raised to minus bx divided by x dx. Okay, so what rule says, when you try to differentiate I of a, this is the rule 1, Leibniz rule 1, with respect to a, this is nothing but integral 0 to infinity, partial differentiation of the function with respect to a. So note that since I'm partially differentiating this, other two are constants here. That means b and x is a constant here. Okay, so what is it equal to? 0 to infinity. 1 by x is anyway constant, take it outside. Note that b into x, b and x both are constant, so e raised to bx is also constant, so derivative of this term is going to be 0. What is the next term derivative? Here please note that with respect to a I am differentiating, x is constant, so derivative of this is going to be minus x into e raised to minus ax dx. X get cancelled, remaining is 0 to infinity minus of e raised to minus ax dx. Now integrate this in a regular way. So this is equal to e raised to minus ax minus, already sign is there, and divided by minus a. This minus minus become plus and limits are from 0 to infinity. Now note that when I am substituting upper limit, e raised to minus infinity goes to 0, upper limit is 0. When I am substituting x is equal to 0, e raised to 0 is 1. So this is, lower limit is 1 by a. But this is with the negative sign, since the middle sign is negative always. So what we have, di by dA is equal to this. Once I am reaching to this step, I am going to use variable separable method. So what do we have? di is equal to minus 1 by a into dA. Integrate this. So what do we have? I is equal to minus of log of a plus c. And this function is nothing but I of a. Now note that as we discussed in earlier video, since the given equation involves x, b and a, to figure out value of c, I am going to substitute here a is equal to b. So if this is my equation 1, in 1, when we substitute a equal to b, what we have? I of b is equal to minus of log b plus c, right? So to find out value of c, it is important to find out I of b. So to figure out I of b, let's go back to original equation. So here in this equation, I am going to substitute a is equal to b. So let's see what we have. So in the original equation, I of b I am substituting, which is 0 to infinity. The first term was e raised to minus ax, but a is equal to b now. So this is e raised to minus bx minus e raised to minus bx, and this is divided by x. Clearly this is 0. Integration of 0 is a constant, and that constant particularly I am choosing equal to 0. Right? So what we have, I of b is equal to 0. So since I of b is 0, what do we have? C is equal to, I of b is 0. So C is equal to just log b. Right? So since C is equal to log b, let's go back to in equation 1. So what is equation 1 now? I of A, this is equal to minus of log A plus C is log B. This is nothing but log of B by A. And what is I of A? I of A is 0 to infinity e raised to minus ax minus e raised to minus bx. This is divided by x. This is equal to log of B by A, right? And which is the required thing. So I quickly summarize one more time. First of all, if x, a and b involved in the equation, just try to differentiate the equation with respect to a. So what we have, I of a is equal to the given equation. Differentiate that equation with respect to a so that you will reach to up to this state. When you differentiate this, you are going to get d of I divided by d of a is equal to terms in terms of a. So variable separable method, find out the solution for that. It will involve c. Since it is involving c and given equation involves x, a and b, in that case I am going to substitute a is equal to b to find out value of c. So in one, when you substitute a is equal to b, you are going to get this equation. Left hand side involves I of b. So to find out I of b, just go back to I of a. Here substitute a is equal to b in the equation. The numerator becomes 0. So take that integration equal to 0. So and resubstitute back I of b equal to 0 in equation 1 and you will get the required thing. Yeah, that's it. Hence the proof.